The population of Florida is 19.8 million, and the area of Florida is 65,758 square miles. We're going to do three parts to this problem. We're going to express the population of Florida in scientific notation. We're going to express the area of Florida in scientific notation, and then we're going to use scientific notation to calculate the number of people per square mile. And we're going to express that answer in scientific notation with the proper number of significant figures. In letter A, express the population of Florida in scientific notation. Well, the population of Florida is 19.8 million. Okay, well, million means times 10 to the 6th. If you recall, million is 6 decimal places. So we can start by saying this is 19.8 times 10 to the 6th. But hopefully the bells are ringing because this is not scientific notation. Our first number must be between 1 and 10. 19 is bigger than 10, which means positive exponent. So when I say I need to move my decimal one place over, that means my exponent's going to go up by 1. So in scientific notation, I have 1.98 times 10 to the 7th. And there's the population of Florida. Now the area of Florida, 65,758. Well, decimal's at the end, and I want to move it between the 6 and the 5. So 6.5758 times 10 to the 1, 2, 3, 4. And looking at the front numbers, between 1 and 10, so voila, that is scientific notation. Now, in part C, number of people per square mile. Per implies a division bar or a fraction bar, either way you want to think about it. So we're talking about people per square mile. So we know, based on parts A and B, that our population is 1.98 times 10 to the 7th, and our square mile is 6.5758 times 10 to the 4th. And now we can do just a little division. So we start with our numbers, and we just divide 1.98 divided by 6.57. And I get an answer something like 0.301104. And it goes on further than that, but I'm going to go ahead and just stop it there. And then we go and we do our exponents. Division, same base, we subtract. 7 minus 4 is 3. Well, our answer says express your answer in scientific notation. So let's start there. Our first number here is 0.3. That is not between 1 and 10. That is small. Less than 1 is small. So I need to move my decimal, and because it's a small number, it's going to make my exponent go down, right? Small numbers, exponents go down. So I'm going to move my decimal one place to make it 3.01104. And because I only went one place, my exponent's only going to go down by 1. So I have times 10 to the 2nd. And now we have to think about significant figures. I'm going to go ahead and just look at this problem here. You will see in the top, 1, 2, there's 3 significant figures in the top. 1, 2, 3, 4, 5 significant figures in the bottom. Well, we play that you use the least number of significant figures. So we're going to use 3. So when I look at my problem, 3.01104 times 10 to the 2nd, and I want to go 3 significant figures, 1, 2, 3, that means I look at the number past, what am I going to round to? Well, that 1, where the arrow is pointing, it's 1. 1 rounds down. So my final answer will be 3.01 times 10 to the 2nd.